For this video, we're going to start into potentially the first geometry stuff on the channel, I think. So this is specifically for my students going from Algebra 1 into geometry next year. I tried to do a little research, and this looks like some of the earlier geometry topics that you'll start on in that class. If anything, it'll help kind of give you a pathway or an open door into those topics, or maybe this is something you could pull up a few days before you go to geometry at the end of summer, and it'll get your mind thinking about it. So for this one, it's talking about lines, line segments, and rays. So it's a little bit of vocab based, but we'll try to highlight each. I don't know if that'll take us a super long time, and then we'll talk about kind of the differences. Okay, so let's go ahead and get into it. For this one, it just says, what is this? And it gives us a picture. And then it gives us our three options that we talked about here, the lines, line segments, and rays. So you've probably heard of a line before, but maybe you haven't got super specific with the definition. So basically the difference is, here, let's use this to make things a little bit neater. If we have these three, a line continues infinitely in each direction. So you would see that represented by an arrow on both ends. Basically what that says is it doesn't have an ending point on the right or on the left. It's infinite in both directions. It keeps extending and extending. For geometry purposes, that means there's an infinite amount of points on a line. So if this was on like a coordinate plane, you could find an infinite number of points to plot that fall on this line itself. Let's label that. So that is a line. Next, it tells us a line segment. So we could leave it just like this actually, or maybe kind of like this picture has a point on the end. Maybe I can add something like that here. So point and a point, maybe that's a little easier to see. Basically two stopping points. So it has unlike the line, it has a finite stopping point on each end. So it has a last point and a first point, or vice versa. It stops at a certain, literally, point. So let's label that as well. Line, there we go. Segment. It's alright that it runs over, that's okay. And then finally we have a ray, kind of like a mashup of the two basically. So on either end there will be the arrow, and on the opposite one there will be a point, and this could be flip-flopped too. Basically what that means is it has a definitive end point on one end, but on the other end it goes on forever. So like I said, it's kind of like a mashup of the line and the line segment. It's a ray. Think of it like a sun ray, where you would have like the sun with a ray of sunshine coming off of it, something like that. So let's label that as well. So now we have to think about this picture that they give us, which does it align with? So we see that it has a point on one end, and that arrow on the other end tells me that it goes on infinitely, forever. If I look at my options here, which one has a point on one end and an arrow on the other? That would be a ray. So that's how we can tell the difference here. Let's actually leave this up. It'll be helpful for the first couple. So what is this again? It gives us the picture. This one has two endpoints, so I would go over to the diagram we just made, look at which one has two stopping points. That would be the line segment, so that's how I would know to go with that one. And it's nice that it gave us all three, which means this one with the arrow on both ends, that's a line. So now we saw kind of an example of each. We already talked about something like this, but an extra example is not going to hurt us. That would be a line segment, since it has a point on each end. This would be a line because of the arrow on each end. It goes on forever. Okay, so this is where it starts to change up around the 60s for the smart score. What is the name of this figure? So the first thing we got to figure out, is it a line segment, or array? Even though it shows that these 2 points are on the line, we need to look at the ends. So that's an arrow, that's an arrow. That tells me it's still a line, not a segment or not array. We look at only the ends. From there, we need to just type in the 2 letters that it shows, and that's going to create the name of this figure. So if you had multiple lines like this on the screen, if I said look at line XY or YX with a line, you could flip-flop it. You would know to look at this one. So that's how we name these. Let's keep going. Super. Okay, so again, when you're naming, you want to look at the very ends. So this one has an end at V. There's nothing past it. But on the side with U, there is an arrow. So that would be a ray. I have one kind of each. So if I look here, stopping point and an arrow, that's my ray. Now with a ray, it depends on kind of what type of geometry you're dealing with. For this, it's best that we actually label from the end that doesn't have the arrow, so V, to the one that does, U. So even if it's not necessarily in alphabetical order, it's kind of based on the picture. It lines up. The V is with the stopping one, the U is with the arrow. And that would take us to an 80. Let's do one more real quick. This one would be a segment because both ends actually end with a point. And then again, I'm going to go QP. So just the 2 letters they give us. Let's see if there's anything past this. We'll do a few real quick. This is a line because of the 2 arrows, E, D. Is there anything different in the challenge section? Okay, it looks like the same kind of stuff. So at this point, let's flip to the next one I want to talk about. So this was B1 in geometry. This one doesn't have a number yet, but it is properties of planes, lines, and points. So just another thing to get us thinking about geometry and how it works. So now we know what a line is. We know what a point is from like algebra. We might not exactly know what a plane is, even though you've talked about like a coordinate plane. We'll talk about that a little bit too. So it starts by asking, is the following statement true or false? A line is 0-dimensional. So we need to start thinking about like shapes. Think about like area versus volume, 2D versus 3D, and kind of what we have there. So we'll kind of label each thing first. The most basic thing that we're going to build with here is going to be a point. So a point is 0-dimensional. There's no width or height or length to a point. It's hard to explain without using the word point itself, but that's all it is. Just represents that value. So that would be an example of 0-dimensional. So I know that this is a line, not a point. So I know this is going to end up being false, but let's talk about the rest. The next thing we can get into is from that point we can build a line. So a line then adds length or height. If I went straight up, we could say height too, but we'll say length. It adds 1 dimension to it. So a line is going to be 1-dimensional. If I keep building another line, this is where I start to create a plane. Think about this as almost like a y and an x-axis, like a coordinate plane. That's where we get that naming from. This is 2D because it has height and length to it. And then finally, to get 3D, so we're thinking like volume, we would want to think about like when we add in like depth to this. So height weight, or sorry, not weight. I'm not weighing this, that'd be wild. Uh, but when we start getting depth to this picture, so when I add this third line across, I still have length here. I already had length, so I'm not adding anything new. Even when I connect here, I already had height, so still this would just be a plane. That's still just 2D. When I start drawing back like this, and I don't know how my art's gonna be with something like this, but when I start getting into a 3D shape where I have depth here as well, kind of like if we talked about an x-axis and a y-axis, this would almost be like a z-axis. So going back into the screen of whatever device you're watching on, that's when we would see a three-dimensional shape. And I think 3D and 2D are probably easier to grasp than 1 or 0. So to recap real quick, just a point like this right here where we started is 0 dimensions. There's no height, there's no length, there's no depth to it. If we went just across or just up, we're adding a dimension. When we do both of those, so across and up, that's 2D. And then when we start going like back into the screen and make a 3D shape like this, not a cube, but maybe like a rectangular prism, something like that, that's when it's 3D. And we said this is a line, not a point. So that's how we know this one's false. Let's keep going. A point is 2-dimensional. So we just said a point is 0-dimensional. That's the bare minimum we can have. So this one's not true either. Is the following statement true or false? So this takes us back to our previous one. Array has an endpoint. So that is actually true. Is it still pulled up over here? Yeah, so array has a single endpoint. That's one of the things we talked about in B1, so we know that is true. It's kind of tying the two together. A plane extends forever. So let's think about that one now. I'm going to change the color real quick. Let's go with red, and let's do the square. Or we'll start with a line, then we'll probably go to a square. So we said, kind of like the front face of this shape that we made before, a plane is 2D. So that means we can think like a, oops, the color didn't change. We can think length and height, something like that. And I also mentioned that we can think about this as like a x-axis, a y-axis. Think about what you know about an x and a y-axis. They extend forever. They have this arrow on the end to show that they extend forever. So theoretically, they keep going this way as well. They keep going down as well. So even if this is a y and an x-axis, in every direction it extends. However, I don't have depth yet, so it's still 2D. So this is a plane. A plane can also be represented by, let's see how perfect I made this. A little iffy. Just a face of a 3D shape, just like one side of it, essentially. And we know that does go on forever. Okay, let's rewind a little bit. There we go. A line segment extends forever in one direction. So if we look back at what we had before, it's actually the ray, we talked about that a second ago, that extends forever in one direction. The segment stops on both sides, so that's not true. So this is a little, like I mentioned before, vocabulary based. As long as you're starting to get these ideas of what these words mean down, then you should be fine. Might have to run through them a few times though. A line segment has 2 endpoints. Okay, that's what we just got done talking about. The segment does have 2 endpoints. A stopping point and a stopping point. So that one is true. The intersection of 2 planes can be a line segment. So for this one, sorry about that. Two planes or two lines in a plane are perpendicular or do not intersect. So think about what two planes would look like, or two lines in a plane. So we need a plane first. So remember, that's 2D. That's like one side of the shape we just had. Two lines in that same plane. So let's say this is one line, and let's say this is our other line. And we know that lines go on forever. That means that they're always going to intersect unless they are parallel. So this wording is off a little bit, I think, here. I think if that said parallel, then we would be good, but I'm going to say based on that wording, it would be false. Okay. And we're at 70 now, but let's look a little bit further. Every line segment has a length. So think about what we had here with a line segment and its two stopping points. Basically what that means is those are two separate points. So as long as they're separate points, there has to be some distance between them. Otherwise, it would be the same point on top of itself, and we would have just a point, not a segment. So it's kind of based on the name again. We talked about a little bit ago, a plane has an endpoint, or if a plane has an endpoint, and we said that because of what we know about coordinate planes, like an x and a y axis, we know that on the ends of those, when we draw a coordinate plane, that it goes on forever. So this one should be false. It doesn't have an endpoint. And then let's do this one as a wrap-up point. Here, a line does not have any endpoints. We know a line with the arrow on each side means it goes on forever. So that's true. It doesn't have endpoints. Alright, so we'll call it there. Hopefully this helps and kind of opens the door for you going into our next kind of math with geometry. Thanks.